All right, so let's take care of the last bit of this naming. Looks like 8 or 9 slides are left here. So we were seeing the oxyanion pattern in the last video, right? Sulfate, sulfite, nitrate, nitrite, phosphate, phosphite. Well, we're going to see that again with chlorate, but with the halogen-based oxyanion, so anions containing oxygen, chlorate, bromate, iodate. In addition to having the one variation by dropping an oxygen, we also have perchlorate, where we add an oxygen, and hypochlorite, where we drop another oxygen from the chlorite. So there's 3 variations from the parent ion, and I call it that since there's no variations and it has the traditional ATE ending. But now you see there's 3 variations for this one. So it's only unique to chlorate, bromate, and iodate. Those are the only 3 where this rule is going to happen. Where we have these 3 variations from the original parent. So that's what you're going to see in our first bit of naming here. So here it's showing all of the variations, and the prefix hypo to be fewer than the chlorite and per to be more than the chlorate. So these are the 4 total that we have. Okay, so we're going to start by just incorporating these names into names with the alkali metals and alkaline earth metals, so we don't have Roman numerals to deal with. So we'll start by identifying the anion in each case with its name, and then we can just fill out the rest of the formula from there. So ClO, 1 oxygen, so that's hypochlorite, and it's paired with potassium, so that's just going to make it potassium hypochlorite. The next one, we've got BrO2, so 3 oxygens is the parent, ATE, so 2 oxygens is 1 down from the parent, so rather than bromate, it's just bromite. So that's going to be lithium bromite. Let's see, this next one, we're back to hypochlorite again, right? So that's going to be calcium hypochlorite. Next one, ClO4, so 4 is 1 higher than the parent, so that's perchlorate. The hypo is smaller than, like hypodermic needle, and the per is like hyper for more than, so that's how those prefixes work. So now we're at sodium perchlorate. Last one here, that's BrO4, so not perchlorate, but it's going to be perbromate. And Sr is an alkaline earth metal called strontium. So this is strontium perbromate. Okay, so that's the next rule. Now we're going to start to talk about acids. And so whenever we're talking about an acid, that means we're referring to a molecule that has H plus as its cation, but also to officially get the name acid, the molecule needs to be neutral overall. So we'll kind of see all the variations we've gone through so far: single atom anions, parent polyatomic ions, non-parent polyatomic ions, and all of that will come into play here. So if we have an anion that ends in IDE, which typically means a single atom anion, then we're going to add the ic acid ending to indicate that it's an acid. And if there's no oxygen as part of the anion, then we indicate that with the hydro prefix. So if the formula overall doesn't have an oxygen in it for the acid, it'll get the hydro prefix. So HCl, so that's an H plus and a Cl minus combined together to make HCl. It gets the hydro prefix because there's no oxygen, and the neutral molecule with hydrogen plus as the cation, that's an ic acid, so it becomes hydrochloric acid. Same thing happens for hydrobromic acid and hydroiodic acid. Okay, so that's what happens with our single atom anions. Now, if we're dealing with a polyatomic anion paired up with H+, then there won't be the hydro prefix. We'll just go directly to the name, like chloric acid or perchloric acid, or nitric acid or sulfuric acid. Let me see which ones I included here. I can write a few more on this slide. HNO3 is just nitric acid. And again, all of this is included in handout 3. H2SO4 is sulfuric acid. H2CO3, so now we're paired with carbonate, that's carbonic acid. And then we could also have phosphate, H3PO4, phosphoric acid. So all of these that contain oxygen with these oxyanions, they don't have the hydro prefix. So comparing chloric acid to hydrochloric acid, right? HClO3 is chloric acid, but HCl is hydrochloric acid. So that's how we make the distinction. So once again, to get the acid nomenclature, it needs to be a neutral molecule where the cation is one or more H+. So that's how we're getting these formulas. So what we've seen here has been with the parent oxyanions, but in the last video we saw the non-parent oxyanions. So we're going to see the acid names also for the non-parent oxyanions. So we'll do that next. So now we saw that if we had two oxygens or one oxygen, the ending would be ITE. So the ATE ending gives us ic acid. The ITE ending gives us OUS acid. So if I have a prefix like hypo, it just carries over to the name of the acid. And that was true here as well, right? If I had the prefix like per, I carry it over to the acid name as well. And if I don't, if it's just the one oxygen down from the parent, then it's just chlorous acid. So this would give me, in addition to this, hypobromous and bromous, hypoiodous and iodous acid. But then I could also have HNO2, which would be nitrous acid. That is neither laughing gas nor what you put to make your car go fast. It's just nitrous acid. We could also have H2SO3, so not sulfuric acid, but sulfurous acid. And then with phosphate, same thing, right? Rather than PO4, we could have PO3. It's -3, just like phosphate, so I need 3 hydrogens. So this would be phosphorus acid. Okay, so let's do some examples of these. I think that's it for the acid naming practice, and I think there's one rule left after that. Okay, so I'm going to identify the polyatomic oxyanion in each case, and then we'll switch over and give it the acid name. So let's use red, I guess. So ClO, that's the lowest version, so that's hypochlorite. So we get hypochlorous acid, right? The ITE ending in the anion becomes OUS acid in the acid. The next one, BrO2, that's one down from the parent, so that's bromite. And ITE becomes OUS acid, so not hypo, just bromous acid. Okay, next one, that's ClO2, so one down from the parent, so this is going to be the same as the one above, chlorite. Oh, ITE here became OUS acid, now ITE here, also OUS acid, chlorous acid. Then the next one's just the parent, right? IO3, that's iodate. And so that simply becomes iodic acid, ATE, ic acid. And lastly here we have not bromate, but per-bromate. So the per will carry over to the acid name, and then ATE will become ic. So this will be per-bromic acid. So again, ic acid to correspond with the ATE ending. So I think the acid naming is kind of the most confusing because all of the rules come together at that point. But if you follow kind of systematically how we've approached all this, going from one step to the next, hopefully it's making reasonable sense. And the handout 3 and problem set, I guess it should be 3, those are the things that you want to focus on the most to really get your naming stuff down. Okay, last rule is modifying our oxyanions by adding hydrogen cations. So to make an acid, we add hydrogen cation in order to make the molecule neutral, however many we need. But for things like sulfate or phosphate or carbonate, I can add 1 or 2 hydrogens to it without making the neutral molecule, and that's just going to generate a new oxyanion that we just add the word hydrogen to. So this is going to apply to sulfate and sulfite, phosphate and phosphite, and then carbonate. There's no carbonate, so those are the 5 where this rule is going to apply. And it's pretty straightforward, right? If I add a hydrogen in front of sulfate, it'll become two words, hydrogen sulfate. If I add a hydrogen to phosphate, it'll become hydrogen phosphate. For phosphate and phosphite with the -3 charge, there's one other variation, and that's where I can put two hydrogens but still not make the neutral molecule, right? It's still a polyatomic ion. And this is for the first time at all in any of our ionic compound naming where you see a Latin prefix like di. All the naming we talk about for ionic compounds, this is the only place where you're going to put a prefix like di. It doesn't show up anywhere else, and it's just di. So H2PO4-, like this one, is dihydrogen phosphate. H2PO3- would be dihydrogen phosphite. Okay, I think I have examples of this naming to do, and then that's a wrap on this chapter and all things ionic compound naming. Okay, so with these ones, just want to identify our polyatomic ions. So HSO4, that's hydrogen sulfate. So this will be sodium. It's three words actually, right? Sodium, hydrogen, sulfate. So there's our hydrogen sulfate. The next one, HCO3, that's hydrogen carbonate. So this one will be potassium hydrogen carbonate. This next one, HPO4, that's hydrogen phosphate, and it's paired with calcium, so it'll just be calcium hydrogen phosphate. All right, now we have HSO3, so it's the non-parent, right? It's SO3 instead of SO4, and I've added a hydrogen to it, so that's hydrogen sulfite. So this will be lithium hydrogen sulfite. There's our anion. This next one, now instead of hydrogen phosphate, dropped an oxygen, so that's hydrogen phosphite. So that's going to be sodium hydrogen phosphite. This last one, H2PO4. So because there are two hydrogens, this is going to be dihydrogen, and it's PO4, so phosphate. So this will be potassium dihydrogen phosphate. Okay, so that's a pretty comprehensive look at all things ionic compound naming. I think, like I said in an earlier video, this is kind of one of your bigger challenges in this class. There's a couple doses of substantial memorizing to do, one here and one closer to the end of the class. But given this condensed 5-week schedule, it makes it kind of tough to knock all these out in such a short amount of time. So I recommend that you focus on flashcards or whatever memorizing devices you feel most comfortable with in order to figure these out. And so if you do that, I think it'll come together. And I really recommend read through all of the handout 3 that I made and then work through problem set 3 in order. It kind of deals with each set of rules one at a time. So once you make it through all of that, then you should feel pretty solid with all of the different naming rules. So hopefully that gets you to the point where you feel comfortable with all of this and you can name all these different ionic compounds. So I'll end this video here. We'll pick up with chapter 5 in the next video.